All right, so we're going to quickly go over that warm-up that you just did. Hopefully you just did, or at least tried. So we're looking at that first one, number one, that's a binomial times a binomial. This is one that I think is really helpful, especially if you're a visual person, to kind of go with the table method here. And we've got a binomial times a binomial. So I'm going to put this first binomial, x plus 3, on the side here. So that'll be an x and a positive 3. And then the other binomial, x minus 10, on the top. And make sure that since it's subtract 10, that makes it negative. Then we're going to fill the table just like we always have back when we were doing multiplication tables and such. And that would be x squared. X times x is x squared. Negative 10 times x is negative 10x. 3 times x is 3x. And 3 times negative 10 is negative 30. The only like terms we have to combine are the x terms here. So that would result in x squared, negative 10, and positive 3 is negative 7x minus 30. Now this one you could do as a table, but since we're really only distributing a monomial on the outside, we can just treat it like a regular old distributive property, right? But just don't forget that when we do 2y times 4y to the third, we're going to get 4 times 2 is 8. Y times y to the third is y to the fourth. And then when we find the product of 2y and 5y, that's going to be 10y squared. And there's our answer. Nothing to combine. 4 y to the fourth and y to the second are unlike terms, so you cannot combine them. Don't try to say that's 18 y to the sixth. Right? Once we're involving a trinomial like we are in number 3, this is where I think the table method is really helpful. Just to keep everything organized, just to keep everything the way it should be, so we don't lose track of anything and we can organize what we're doing. X plus 4, I'm going to obviously put the binomial over here. X squared, 5x, and negative 7. There's my trinomial. And just remember, every time you see a subtraction, when we put it in the table, it becomes negative. And we can't lose sight of our multiplication rules for exponents. So we've got x to the third, right? X times x squared is x to the third. X times 5x is 5x squared. And x times negative 7 is negative 7x. And then bottom row, 4 times x squared, there's our 4x squared. 4 times 5x is 20x. And 4 times negative 7 is negative 28. Now, that we have this, again, if we do the exponents in descending order like we have here, it's easier, right? It's easier to kind of keep track of all the like terms. There isn't any x to the third, but there is some x squared terms. So 5x squared plus 4x squared gives us 9x squared. 20x plus negative 7x is positive 13x. And then minus 28. There's no like terms there. And the other method that we're going to look at in number 4, which is, one I kind of cautioned us against, but it's FOIL, right? The first terms. We're going to multiply the first terms together. And that gives us our x squared term. We're going to the outside terms, the x and the negative 7, because this is a negative 7, really. So it's negative 7x. And then here are our inside terms. This is really the repeated distributive method that we talked about before in our notes, right? Either way, we're going to get x squared, whether we did the table, whether we did repeated distributive, or whether we called it FOIL, doesn't really matter. We're going to get x squared minus 15x plus 56. And then lastly, this is number 3. We're kind of doing the table backwards. We're trying to find out what is the monomial that when we multiplied it by the trinomial x squared plus 5x minus 2 would result in what's here in the table. And it should just be one thing. So if I were looking at that and saying, okay, well, if I'm making the table, I multiply. So if I'm going to go backwards, I'm going to divide. Seems to me that down here, this last one is going to be the easiest to work with. Right? And we do that, we're going to get 4x. And hopefully when we divide everything here, we get the same thing, and it sure looks like we do. Turns out that we do. So the monomial that the question marks represent is equal to 4x. So that's the warm-up that we just did. Hopefully, if you did make mistakes, you could see maybe where you made them, what type of mistakes they were. Remember, not all mistakes are created equal. Right? If you take a look at this one here, if you look at this, say number 3 or number 1, right, where we're setting up the table, if you set up the table properly, that's a step in the right direction for demonstrating understanding. If you filled out all the table correctly, if you got x to the third, 5x squared, negative 7x, 4x squared, 20x, and negative 28, that's another step in the right direction to demonstrate that you know what you're doing. If you made a mistake combining like terms, that's something else. That's a different type of error. That might not be as big of an error because you showed me what you were doing. You made a math error. Okay? So hopefully this made sense. Hopefully if you did make mistakes, you're catching them what they are doing, where they're being made and that sort of thing. All right? So hopefully this made sense and hopefully this helped. And please let me know if you have any questions.